Hello, am I audible? Okay, so if you have any doubt from the last class, then yeah, please tell me. Hello. Yeah, so please let me know if you have any doubt from the last tutorial session or last the maybe mainly for week 4. So if you have any doubt, you ask here. Otherwise, I will start in 1 minute. Okay. So last class, what we did the differentiability of the two variable function and continuity, I think, and or continuity of the first derivative, all these things, partial derivatives. So if you don't have any doubt, then we'll move to the today's session. So this is your fifth tutorial session, week 5 tutorial session of week 5. So this is Rahuldev Ghorai from Aisa Tiruvananthapuram. So the the topic for whatever we will discuss today, those includes improper integrals and the two special functions, the two special type of functions are beta gamma function and beta function. Okay. So to begin with, like we have integrals of type this. We have some. 1 minute, okay. Yes, so we have mainly two type of integrals, which we say the definite integral and indefinite integral. Okay, so one is definite integral, and another is indefinite integral. Okay, so uh, so you have seen maybe the function like the integration like x square, the just integration of this, which will be nothing but x cube over 3 plus a constant. Okay, so what is this? Nothing but the antiderivative of x square. When if you take derivative of this quantity, it will give you x square. You don't get a proper value. It's just a function. This integration, indefinite integral, like, take one function, give you another function or another sequence of functions. Okay. So, but if you go for the indefinite integral, what it is, indefinite integrals are those integrals, they will be like a value will be there. I mean, if you take x square the under the domain 0 to 1, I mean, if I start like this, I mean, this is a function of this is x square, right? Y equal to x square. Now, if you have the domain is from 0 to 1, it's a 1. I mean, the indefinite integrals gives you nothing but the area under the curve, right? Area under the curve. Now, these indefinite integrals can be many types. Suppose you have a function and you have it's keep on going and you have to integrate from let's say from a point half to infinity. Means you don't know. I mean that domain is unbounded domain, or the or you have to maybe you have to integrate from -1 to minus infinity, or maybe you will see, although it is like the integral is bounded, the domain of the integral is bounded, but the inside the that bound inside the domain, the function may be discontinuous. I mean, let's say one example is like 0 to 1, 1 over x minus half. Can you just take can you just evaluate the integration, because this you can evaluate, you will evaluate, but the thing is at half x equal to half, this will be discontinuous. It is going to infinity. I mean, you don't have any value for this function. So inside 0 to 1 you have a discontinuity, not defined value. So these three type of functions mainly we will see they are improper integrals. Okay. So improper integrals are coming from the indefinite integrals which are of this type. So where I have written it here. So you see, when we will need all these things to do the problem, solve the problem. So that's what I'm doing. An integral is a improper integral if the integrand becomes infinite within the interval, or if the integration is infinite. Interval of the integration is finite. And now the thing is, if the interval is infinite, then if you have this type of a to infinity fx dx, then we can write like this as limit r tends to infinity a to r fx dx. If minus infinity to b fx dx is equal, if it is like this, then you can take limit as r tends to minus infinity r2. And this integration is our like 0 to 1 by x minus half type of integration. So if this type of integration is there, so what you have to do, you have to mainly the integration at half you have difficulty, so you take from 0 to half and then half to 1, so you don't include that half point by taking limit. See, limit as epsilon raised to 0 plus a to c plus c minus epsilon we will take. I mean, here it will be 0 to c, 0 to half minus epsilon of 1 by x minus half plus the another this quantity. So if you have this type of problem, then you just you just split it and you write it like this. Okay. So any doubt in this theory? This theory part. So if you have like x 1 by x minus half type of thing, then you take 0 to half minus epsilon and half plus epsilon into b and take epsilon next to 0. That will be, then you can evaluate like that if it exists. First of all, you will see if it exists, then you can evaluate like this. So now, depending on the definition of improper integral, can anyone tell me whether this is improper integral? First one. What about this? Is it is it improper integral? What is the property of the improper integral? First of all, the domain where you are integrating, that is 0 to 1. So bounded. So that first condition is not satisfied. If it is unbounded, then you can say that for any function that will be improper integral. But in from 0 to 1, do you see a discontinuity of the sin x by x? Sorry, yeah. Sin x over x is discontinuous on 0 1, or limit does not exist. Mainly not discontinuous, limit does not exist. Do you see anything here? Although you see, if you just put 0, that might not be defined. At 0 it might not be defined, but the limit you take, limit as x tends to 0, we have already observed sin x over x, that is 1, right? It is finite, right? So the thing is, this function sin x over x, the limit of sin x over x exists always in 0 to 1. So the integral here is not improper integral, it's a proper integral. The value and all we will see how to find out later maybe, but at least you can say it is not improper integral. Right? You understand? So if that is so, then what about this one? Sin x over x, 0 to infinity. Is it improper integral? Hello? Can you hear me? Can anyone reply whether you all are here? Okay. So, what about this? Is it improper integral? So, the first condition, the boundedness of the domain, that itself is not there. I mean, it's unbounded domain, so it has to be improper integral, right? Yes. So, this integral is in improper integral. I'm just giving you an example. Okay, so Ananya is telling something. So if you, she is telling, if you from 0 to infinity sin x over x, you have that you can split it sin x over x plus 1 to infinity sin x over x. Now what he is telling, the first one is the first integral, that is already we have seen it's not improper, it's a proper integral. And the second integral, that is improper. But why? Ananya, can you tell me, just explain it? Why it is improper?
Sir, because the limit is infinity, upper limit.
Limit as infinity. Okay. Let's take limit as infinity. Okay. Limit as x
No,
tends
sir,
to
the upper limit, like the integral has to be evaluated from 1 to infinity, so that is not bounded. The interval is not bounded.
sorry, once more.
Sir, the limit of the integral, the interval in which we have to calculate, that is not bounded. That
Why?
is
Why
infinity.
that is so? What do you mean by limit is not bounded? Limit exists or does not exist? Limit is unbounded mean? Limit does not exist. See, this one is just making you confused. So this quantity, the domain itself is 1 to infinity is unbounded, right? So this one will be improper integral only. Convergent divergent is different. This is improper integral. You don't need to first of all split. Even this here itself you have seen this 0 to infinity is unbounded integral, unbounded domain. So unbounded domain means the integral is improper. Now the thing is improper integral can be convergent, can be divergent also. I will give you one example so that you don't get confused. See, so leave this example. So we'll do some. Okay. So now let's do in the first page. Okay. So if you have a, uh, let's say this is 1 to infinity 1 by x and 1 to infinity 1 by x square. So both the integrals are improper integrals, right? Correct?
Yes, sir.
Yeah. So the domains are unbounded domains. So these are improper integrals only. Now we will see what both they behave very differently. So as I said, how we will evaluate this? Limit will be limit as r tends to infinity 1 to r 1 over x, right? This limit, this integration you can write like this. Then limit of r tends to infinity. This will be ln x, which will be evaluated from 1 to r, and that is nothing but limit as r tends to infinity ln r minus ln 1, that is 0 ln, so that will be limit r tends to infinity ln of r, which is infinity, right? So 1 to infinity 1 by x, that's improper integral, that diverges. So this diverges. So we can say that it is divergent. But see here, what is the difference? Limit as r tends to infinity 1 to r 1 over x square. I mean dx is always there. I haven't written. Okay, so dx, that will be limit as r tends to infinity. This integration is minus over 1 by x 1 to r. So that will be limit as r tends to infinity minus 1 by r plus 1 over 1. What is this? Limit as r tends to infinity 1 minus 1 by r, that is nothing but 1 and converse. See how beautiful is, like the, you take 1 by x, uh, it diverges, but if you take 1 over x square, it converges. So both are improper integrals. So here the difference is this: the improper integrals does not imply it is divergent or it is always divergent. It can be convergent also. I think some of you might make mistake while doing these things. So this is the difference mainly. You will see the difference here. So yeah, you can draw the graph of the function maybe mainly. So how this 1 by x 1 by x y will be equal to 1 by x. Let's say it is 1, then it will be 1 1, and here will be also it is 1. But if you go beyond, say, so what about 1 over x square graph? So if you take some value, say 2, this will be half and this will be 1 over 4. So it will be less. I mean, it might be like this kind of, at least from here it will be like this. So maybe they are looking same, like graphs will be looking same, but the what I want to say, the if you take the area under the curve, one will be convergent, one will be divergent. Okay. So yeah, I'll just draw the proper way. Just 1 minute. Yeah, it will be like this only. I mean, it's you draw it like this, it will go and it will be like this. So same type of curve only. See, they look same. I mean, it will be here and there, but uh, if you so one point they will meet, and then 1 by x square will be this one will 1 over x square curve, and this is 1 by x curve. So they look similar type of, but if you take area under 1 to infinity, this is 1 to infinity. If you take, then the one convergent, one converge, one diverge. Okay. So yeah, let's move to the first question of today's class, today's tutorial session. So how to evaluate this? So 0 to 1, 1 over x to the power 7 over 8 dx. So where you see the problem here? The problem is only at 0. So what we will do? So first of all, first, first find out where the function is not defined or has no limit. So in this case it is 0. 0 it is diverging. So we take limit as, let's say, r tends to 0, r to 1, 1 over x to the power 7 over 8 dx. That gives you limit as r tends to 0, and this integration will be minus 7 over 8 plus 1 over minus 7 over 8 plus 1. This from 1 to r, and that is nothing but limit as r tends to 0. Sorry, r tends to 0. This will be r to the power, I mean, first of all, 8 will be outside, right? So times r to the power 1 over 8 minus 1, right? That will be nothing but minus 1, sorry, minus 8. So it's a finite value. So you see the value of 0 to 1, 1 over 6 to 6 over 7 over 8 is a finite value, is finite, and it is convergent. So when you have a finite value, you say that it's convergent, and 0 to 1, 1 over x to the power 7 over 8 integration you can find out like this. Okay. Yeah, so you can put in this formula also, which is already done, and we can check it here also with whatever we got minus 8 solution, that is whether it's coming here.
Sir,
So,
won't it be 8 because the limit is from R to 1 and not 1 to R?
oh yeah, that's correct. I made it wrong. Yeah, so true. Why it will be here from here? So R to 1, it should be R to 1. So it is. I mean, it will be just negative of this thing. Okay, right? Negative of this one. So it will be plus 8, right? Is it correct now? We'll check it
Yes,
here
sir.
also. So the value will be here 1 over 1 minus 7 over 8 times b minus a 1 minus 0. P is 1 minus 7 over 8. That will be 8, right? Yeah. So correct. Yeah, you were correct. You are correct. So I made here mistake. So from instead of R to 1, I took 1 to R. That usual R I made mistake. So usually what you take when something is tending to 0, so you take epsilon, and R that tends to infinity you take. So that will be easier. So otherwise you can make mistake like this. What I made. So this was simple, and this one already it is done. You have seen maybe this formula, so you don't need to maybe remember this formula always. You can just put in, you can find out these things, and you will see if p is greater than equal to 1. This is this one is divergent, and you have seen when p equal to 1, right, and a equal to 0, that 1 over x, that was but not that was not bounded, means it was going to infinity. So if you take this 1 to infinity, that will be 1 to infinity 1 over x, that was unbounded. Okay. Okay, so now we'll move to this is called, so we'll come to this is question 1 is done. Question 2, so how do you find these are first 1 2 questions will be to be easier. So maybe this is 0 to infinity, how you do this one, e to the power minus x, that will be where is the issue, only at infinity. I mean, at infinity it is converging to 0, so usually you don't have problem here. You can take and think like that also. It's a all the improper integrals is from 0 to infinity. So it's unbounded domain, in the unbounded domain, so that's why it is improper integral. So but the thing, it will be limit as r tends to infinity. You can write 0 to r e to the power minus x dx, which will be limit as r tends to infinity, negative of the power minus x, which is from 0 to r, that will be limit as r tends to infinity, negative of e to the power minus r minus 1, which will be 1, right? So e to the power minus r converts to 0 as r tends to infinity, right? That we know. So we use that to find out this. See, this is what it is done. So any doubt, tell me quickly. Otherwise, I am just moving. Okay. So now let's do this one. So can you do it? I'll give you some few minutes to do. So where are the issues, and how to find out the limit. So do it and tell me quickly. In 2 3 minutes, let's try. So it will be good for you. What's the graph of this function? Yes.
Sir, it diverges.
Sorry.
It diverges.
Okay,
The
we'll see. Good that you did it. Okay, we'll try and we'll see. Okay. So what is the graph of this function mainly? So the graph of this function will be like you can check in some software. So the graph of this function it will be at -2. It will be going like this, and it will be at 2. I mean it is x equal to 2, x equal to -2 line. These are, and then the graph will be like this. Okay, so at ±2, the function has no limit, right? uh, no limit. So but -2 is not in our domain of consideration, so we'll take only the 0 to 2. In this 0 to 2, so only the problem will be then at 2. So how we will handle, then we'll take 0 to 2, 2x over x square minus 4 dx can be written as limit as epsilon is a number which is tending to 0, 0 to 2 minus epsilon 2x over x square minus 4 dx. So now tell me about this sorry, yeah, about this integration. Sorry, not this integration, this total integration. Do you see any issue here in this integration? This integration is a definite integration now, right? It has no 2x over x square minus 4 over 0 to 2 minus epsilon is a definite integral. You can just find out the integration, right? So once you can find out this integration, then after that you can take limit. See, 0 to 2. Uh, sorry. 0 to 2 it has issue, but when you take 0 to 2 minus epsilon, this will be proper. Sorry, the proper integral, and this one was improper. So mainly what usually we do, we try to transform improper integral to proper integral and then take limit. Right? That's what we are doing. So now we'll evaluate how to do this, how to do this integration. We'll see. See, this is the hint for the solution. We do it like this: C0 to, you can take like this. Epsilon tends to 0 to minus 2. Also, you can take like this. then there is a way to do like this. I'll send this anyway. This PDF will be shared with you. No problem. I'll do this one. Limit as epsilon tends to 0. Let me write it fully. So this is nothing but 0 to 2, 2x over x square minus 4 dx will be nothing but limit as epsilon tends to 0, 0 to 2, 0 to 2 minus epsilon 2x over x square plus 4 dx, right? So now if you take x square plus 4 equal to some t, then you will see dx 2x dx will be dt, and what you can write this integration as 0 to 2 minus epsilon dt over t, that is nothing but limit as epsilon tends to 0 ln of 2 minus epsilon minus ln of 0, which is undefined anyway. So did we make any mistakes? I think 0 to
It's
2.
x square minus 4.
Yes. Yeah, so what we made the mistake here, can anyone tell me? I understood what I made mistake here. So what is the mistake? From I'll tell you, from here to here we made mistake already. Okay, see, you will learn like this only. You have to find out mistake in the teachers, like whatever they are doing. So this limit will change now, right? You are changing the integration x square plus 4 is equal to t you made. So then when x equal to 0 t will be 4, and when x equal to 2 minus epsilon t will be 4 plus 2 minus epsilon whole square, right? So that will be nothing but limit as epsilon tends to 0. So, okay. Mistake again. X will be 2 minus epsilon x square plus 4 is equal to t. So 2x dx will be dt. So instead of x square, you can put 4. So when x equal
Sir,
to
it's
0,
actually x square minus 4 in the question, not plus 4 minus 4.
sorry.
Sir, it's x square minus 4.
Ah,
T
yes,
has
yes, yes,
been
yes.
taken.
Good, 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 good. Thank you, thank you. So it is x square minus 4. Yeah, yeah. Yes, yes, yes. So then it will be, yes, now it is correct. So x square, that will be 2 minus epsilon whole square minus 4. Okay, okay. Yeah, now it is correct. So ln of t, which will be evaluated at 4 to 2 minus epsilon whole square minus 4. That is nothing but equal to limit epsilon tends to 0 ln of epsilon square minus 4 epsilon, right? Minus ln of 4. Now this quantity does not, this tends to infinity, minus infinity. This tends to minus infinity. Ln of epsilon times epsilon minus 4 tends to minus infinity as epsilon tends to 0, right? I just made 2 minus epsilon whole square, 2 minus epsilon whole square minus 4. That quantity will be 4 minus 4 epsilon plus epsilon square minus 4, that is epsilon square minus 4 epsilon, right? So if you take limit as epsilon tends to 0, that converts to minus infinity. This integral is not convergent, it is divergent type of integral. So, if you take 0 to 2, although the domain is bounded, you are only integrating from 0 to 2, still the integration is not finite. Okay. Yeah, hope everything is okay till now. If you have any doubts, still, if you please ask me. Any doubt here? Okay, so how to find out the uh, test the convergence of these integrals 1 to infinity. Let's say when you have 1 to infinity e to the power minus x square dx. How do you find the integration for this type of questions? I mean, how to test that whether it is convergent or divergent? What we do is usually we take try to find out whether this if suppose it's something like a to infinity f dx is there, and that is less than equal to a to infinity some known function g dx, and if this one convergent, then this one will be also convergent, imply. So this is like a comparison test. You are comparing, right? Here you are comparing that if and f and g. So remember that both are positive functions. Okay. So for the positive functions, you will see if it is one function is less than equal to another function, integration of one function is less than equal to integration of another function, then the function it's the right hand side function is uh, convergent, and the left hand side function will be also convergent. Okay.
Sir, I have doubt in previous questions.
Okay, let's go to the previous question. Okay, where is that is the
Sir,
question?
that boundary of 4 to 2 minus epsilon square minus 4. How to take, how to know if I have to take 4 as lower bound?
No, here see you have made change to x square plus 4 to t.
Yes.
So now the point here from x is from 0 to 2 minus epsilon is there
Yes, sir.
initially. Now when you put x square plus 4 equal to t, then you have to make sure that this x square will be less than equal to 2 minus epsilon whole square, less than equal to 0. And if
Yes.
you add 4 on both sides, then it will be x square plus 4, that is less than equal to 2 minus epsilon whole square plus 4. And this x square plus 4 nothing but t. That's what you see. T is from 4
4.
to 2 minus epsilon square plus 4. That's what you will get here.
Okay.
Do you understand now?
Yes, sir.
Okay. Good. So if you have any other question also, tell me. Otherwise, this is the comparison principle mainly. The comparison principle, it says that if f, the integration of a function f is less than equal to integration of function g, and f and g are both positive functions, then we can find out if the g function is convergent, then so integration of g is convergent, then integration of f will be also convergent. So using this, can anyone tell me here quickly whether 1 to infinity e to the minus x square you can write in a simpler form? I mean, it can be, you can write less than equal to some known function, or known integral which is be convergent.
So e to the power minus x square can be written as 1 divided by e to the power x square, and it will be less than 1 divided by x square.
It will be less than equal to 1 divided by x square.
Yes, sir.
Yes, then
And then, sir, for 1 divided by x square, we know that there is a property that when we have 1 divided by x to the power p, and when p is greater than 1, then it converges. So,
okay. I think someone wants to join. I will just. Okay. Yeah. So what you are telling is 1 over e to the power x square is less than x square. That also you can do. Okay, that's good. That's one way. So I can do in another way also. Someone else can tell me. So this is always true, right? So x square will be always greater than 1. Sorry, I mean, what I'm telling is e to the power. Uh, how you make sure that this is true? Okay, that's what I'm trying to tell. So what you have is e to the power x. E to the power x will be greater than x when x is greater than 1. That's what you need to prove, right? That's how that will be true, right? You know, and if you take fx equal to e to the power x minus x, then the derivative of that function will be e to the power x minus 1, and which will be always greater than no, first of all, so what I'm telling, this one we have to make sure that it is always true. Okay. So till now, what we know that e to the power x is greater than x plus 1, right? We don't know e to the power x is greater than x or no. Yeah, that's fine. That's fine. So we can do it. So I'll be writing here maybe. Okay. So what is telling that e to the power x square, that will be always greater than x square, greater than equal to when x x square is greater than equal to 1. X is greater than equal to 1 means x square is greater than equal to 1. So this you can prove it. Take fx is a function which is e to the power x minus x, then f dash x will be e to the power x minus 1, and this quantity will be always greater than 0 uh, for x greater than equal to 1, and that's why you can write fx will be greater than f1, which is greater than 0, because that is f1 is nothing but e minus 1. So that's why e to the power x will be greater than x, and that's why you can show that 1 by e to the power x square is less than equal to 1 by x square. And once you take 1 to infinity, 1 to infinity, both are positive functions. So, and this one you know it is convergent. So this one will be also convergent. Okay. Is okay. The first one. So similarly, try to do second one. I will do this. Give you this 1 to infinity sin square x over x square. These are positive functions, so you can use the comparison principle. So how you do that? This one will be less than equal to 1 to infinity 1 over x square, right? Always. That implies this one also again convergent. So this integration will be also convergent. This integral also convergent. Right? And What about this 0 to infinity? Let's say you have 0 to infinity dx over x plus e to the power x. X plus e to the power x is positive when x is greater than 0, right? E to the power x function is positive function always, and x is positive is given x 0 to infinity, so this is positive function, and e to the power 1 by x plus e to the power x you can write as, because x is greater than 0, that implies x plus e to the power x will be greater than e to the power x. So 1 by x plus e to the power x, 1 by, so 1 over x plus e to the power x will be less than 1 by e to the power x. That implies the integration of 0 to infinity dx will be integration of 0 to infinity dx, and we have seen this value is nothing but 1. I think we have seen. So this is convergent. So the given integration will be also convergent. Right? Any doubt in this question? Also, you can check the solution, this solution also, whether you can follow this solution also, whether this is also you can follow. This holds true for the integral of positive function, you remember. Any doubt here? Yeah, if not, then let's move to the next question. So let's call this 1 to infinity, this telling 1 to infinity square root of x plus 1 dx, whether this is conversion or not. Can you do it? Can you try it quickly? So we will be using here something called limit comparison test. Okay. So before that, can you try to do it using the just comparison principle? Can you do that using comparison principle? Anyone?
So for first one, we can take that it is less than 1 divided by only root x, 1 divided by root x.
Okay, then
And then again that root x, when we have 1 divided by root x, that means x has power half, which is less than 1. So it will diverge.
no, you cannot use divergent criteria there. Okay, if I remember correctly, then see, I will tell you. If you have a integration like f x dx is less than equal to g dx, then if this one converges, you can say this one converges. But if it is this one differs, then you cannot say the other one will be diverse. So what you can do that case, I mean, to do the comparison principle, you have to find out this fx is greater than equal to some function, let's say g some g tilde x dx g tilde g prime. Okay, I am to just make sure that don't get confused. G tilde different function, and now if this one diverges, then you can say that this one diverges. Do you understand what I'm doing?
Yes, sir.
So you cannot use here the usual comparison principle. Okay? You have to use something called limit comparison principle. What are those? So if you have a function f, so positive functions also those are fine. So f, and if you have a another function g, and if you take limit, like where is the issue? The at infinity it has issue only, so that x tends to infinity, fx over gx is equal to L. If it is L, that is non-zero number and a finite number, then integration f dx converge if and only if integration g dx converge. Now, can you use this to prove that the 1 to infinity 1 to is 1 to infinity 1 over square root x plus 1, this one convergent or divergent? You use the limit convergence principle I just said. Try to use this one. Find out another function gx such that limit as x tends to infinity, fx over gx will be finite. Try it. What will the another function gx? So you have to show that dx over square root f x plus 1, that is convergent or divergent. So our fx is 1 over square root x plus 1. So take gx equal to 1 over square root x. Then we'll see limit as x tends to infinity, fx over uh, gx, that will be limit as x tends to infinity, square root of x over square root x plus 1. That is nothing but limit as x tends to infinity 1 over 1 plus 1 over square root of x. Just we divide by square root of x. That gives you 1 over 1 plus 0 is nothing but
1. So 1 is not equal to 0. So we can say that 1 to infinity 1 by square root x dx converge, this one converges if this one converges or diverges, right? Now we know about this one. So 1 to infinity 1 over x to the power p dx converges if p is strictly greater than 1, diverges if p is less than equal to 1. And here you see p means here p is equal to half, which is less than 1. So this one diverge. So this one will be also diverge. So the integration from 1 to infinity dx over square root of x plus 1, this is divergent. This diverges. Okay. So try to do the second one like this. I mean, this is integration over 1 to infinity dx over square root x 1 plus x to the power 1 by 4. So I'll just wait for a few minutes for your reply. So what you are doing? So what is the gx? Mainly tell me, like how you take the gx so that fx over gx limit will be fx over gx limit will be non-zero finite number. Okay, so did you find the gx function? No. What will be the gx function? This is similarly, it's the power is kind of x to the power half and x to the 1 by 4. So it's the 1 by half plus 1 by 4 type of thing if you take. So gx will be 1 over x to the power 3 by 4, and if you take fx over gx, that will converge to 1 as x tends to infinity. So what you get is this integration of 1 to infinity dx over square root of x time uh, 1 plus x to the power 1 over 4 is divergent, because in 0 to 1 to infinity 1 over x to the power 3 by 4, this is divergent. Okay, so that's here you see the explanation. So if you haven't done that, then you now you just tell me whether it's okay to you, okay for you, that you understood everything. So these are the some of the tests we will have to use many to find the convergence of the integer. Okay. Any doubt here till now? Like any doubt you ask me, okay? So if not, let's move to the sixth question. This says the like find out the convergence. Says the convergence of this uh, integration. First of all, tell me the for which value of m and n this integration is convergent or divergent. I mean, sorry, improper or proper. Okay. You can assume that I think m and n will be positive. That you can assume maximum. So m and n are positive. Okay. So let's assume that m and n are positive. M n are positive. It can be 0 also. Okay. That you assume. Now tell me whether this integration, whether this integral is improper or proper. I mean, properly telling when improper. Any idea? See, what is the thing here? So, let me write. It is x to the power m is there, right? So, x to the power m times sine nx is there. See now, uh, yeah, so I will write this as x to the power n times x to the power n here. So what I'm doing, what I'm telling you is this is the thing. So limit as x tends to 0, sine of x over x or whole to the power n, that exists, right? That always exists, that is equal to 1. So if you make it this sine x to the power m times sine nx, that is like this type of, then one can say that this one will be see, I'll tell here itself. So you see, yeah, so if you make it this x over sine x, limit fx, you take x to the power m times sine n, sine nx, then x to the power m over sine to the sine x, that to the power n time you keep this one. Now this quantity as limit x tends to 0, so it can only have problem when x equal to 0, right? So did I make it a mistake here? So sin x. Do you see the mistake here? I think I took it. This question was taken from the assignment. In your assignment, it was there. One cannot write like this. So x to the power m times sine to the power nx. You cannot write like this. Okay. I think some mistake was the typo is there. I'll just check once your assignment. Okay, your assignment questions, whether this question is like this or it is different. I'll check it. Please give me 1 or 2 minutes. Okay, I'll just check. Or if any one of you can also check, then it will be good also, no problem. I am also searching it. Yes, I think I found out the question. Yeah, so question is not this. Yeah, question will be 0 to pi by 2 x to the power x to the power m over sine to the power mx. Okay, so the problem you will see here only when, see, if x equal to 0, then only you can have it. So now what I do is, this is sine to the power minus nx. Okay, this is sine to the power minus nx. Okay, so what I will do is, I'll try to find whether I can write it in such a way that the limit of this function exists in such a way. So what you will see here, this x to the power m over sine nx. That you can write as x to the power n over sine nx, and this quantity will always converge to 0 time converge to 1 and when x tends to 0, and times it will be n minus m minus n, right? So if we write like this, when x tends to 0, this converges to 1, but this whether converges to 1, which converges to 0 or 1 or infinity, it depends on m minus n value, right? If m minus n is greater than 0, then x to the power m minus n will converge to 0 as x tends to 0. But if m is less than n, x to the power m minus n will converge to infinity. If m is equal to n, then x to the power m minus n is nothing but 1, so that will converge to 1. So depending on the m and mn value, it will be 0, 1 or infinity. The limit of this 1, right? So limit of the function at x tends to 0, this will be 0, 1 or infinity depending on the m and n value. So what you can say that the integral 0 to pi by 2 x to the power m sine to the power minus n x dx is improper when m minus n is less than 0. Otherwise, it is a proper integral, and when it's proper integral, you don't need to find it. You will always you will have a value. Yes. So we need to find first of all when the function, when the integral is improper, and then after that we have to find out for which value it will be convergent. First of all, when m is less than n, then only it is improper. So when m is greater than equal to n, no need to, that will be always convergent, right? That is convergent. Because that will be proper integral, so that will be convergent. So when m minus n is less than 0, then only we will focus. So now when m is less than n, we'll do we'll take a gx function as x to the power m minus n, like we took. It's already done, so don't need to again do. So gx is x to the power m minus n, and if you take limit as x tends to 0 plus fx over gx, that limit will be limit x tends to 0 plus x over sin x, like this we already do, this x to the sin x to the power n over x to the power m minus n, that is always 1, and that is not equal to 0. So by limit comparison test, so therefore by here it will be limit comparison test, okay? Limit comparison test. So limit comparison test, you can say that because this one will converge if n minus n is less than 1, that is easy to check it, right? X to the power m minus n 0 to pi by 2, it has issue in 0, so you can check it. It's convergent when n is less than m plus 1. So the total our integration will also convergent if n is less than m plus 1. Okay, so the converges if n is less than m plus 1. Which one? It's sine to the power n x to the power m over sine to the power n x dx converge if n is less than m plus 1. Any issue here? Do you understand? If not, please tell me.
So please again.
Okay, no problem, no problem. Let's. I think I should again do it. How? Yeah, here. So our integration is 0 to pi by 2 x to the power m over sine to the power n x. M n are positive numbers that you can just keep it. Dx is also there. Okay. So the only issue here can be at 0. So, but we have to find out limit as x tends to 0. I'll check whether this limit exists or not. Sine to the power nx. Now, if this limit exists, this limit exists, then we don't need to do anything. It will be for any mn value, mn positive value, it will be convergent, right? But that is not always true, right? Because if you take maybe like this sign limit as x tends to 0, let's say x square, not x square, yeah, I mean x over sine x square, yeah, x over sorry, not sine x square, sine square x over sine square x. That would be that limit does not exist, right? When all for all x, so what you will see, but x square over sine square x, limit as x tends to 0, x tends to 0, that will be limit as x tends to 0, uh, 1 by sine x over x, that whole square, and that will be 1. So all the x to the power m over x to the power n plus 1, that does not exist. So that's why what I make it as limit as x tends to 0, I made it x to the power n over sine to the power nx, which will always be going finite, limit will be finite, times x to the power minus n, because I made x over n, so x over minus n times x to the power m, that is always there, that is at the end. So which is nothing but limit as x tends to 0, x to the power n by sine to the power nx times limit as x tends to 0, x to the power m minus n. Now this limit is always 1, right? This one you know, this one will be always 1. So this one will be always 1 times, this one now depend on, if m is greater than n, then x to the power m minus n will converge to 0, because m is greater than n, when you take m is n plus 1, then it will be x. M is n plus 2 or n plus half. Whatever you take, that will be some power, positive power. So 0 to the power positive power will be 0 only. So limit, if m is less greater than n, limit x tends to 0, x to the power m minus n will be 0. So in that case, limit of x tends to 0, x to the power m over sine to the power nx will be 1 times 0 will be 0. So limit exists. So the integral, in that case 0 to pi by 2 x to the power m by sine to the power nx is proper integral, right? Proper integral. Why? Because the integration, the given integration is from 0 to pi by 2, which is a bounded domain. And the problem, what we thought at the 0 point, there it has a limit is finite. So the integral is proper integral when m is greater than n. Now let's come to, if m is less than n, limit as x tends to 0, x to the power m minus n, m is less than n, let's say m is n equal n plus n minus 1. So this will be the limit as x tends to 0, x to the power m minus n will be 1 by x type of. So this will be infinity. So this limit as x tends to 0, x to the power m over sine n to the power nx will be also infinities, because x to the power m over sine x to the power m over sine n to the power nx is nothing but in the form of this, and that form is converged to infinity, so this will be infinity. So then it is improper integral. So if m is less than, if m is equal to n, then limit as x tends to 0, x to the power m over sine to the power nx will be 1 times 1, because m equal to n. So when n equal to n, it will be x to the power n over sine to the power nx will be going to 1. I mean, the limit will be 1. So proper integral, again proper integral. So when m equal to n, or m is greater than n, then proper integral. But only problem is, in proper integral means then it is convergent. So don't need to say. So m is, when m is greater than equal to n, that will be convergent. That's not an issue. Now we'll move to in the case when m is less than n. Can we find out a way so that it is fully convergent in that case? So it is an improper integral when m is less than n, right? When m is less than n, that is an improper integral. So what we take is we take gx equal to x to the power m minus n, and we show that fx over gx limit. I mean, I just found out first that when m is less than n, then only the integral is improper. Otherwise, it will be convergent. I mean, if m is greater than equal to n, it will be convergent, right? So yes, so that's the first part, and for the second part, what we do is we take a function gx, which is x to the power m minus n, right? So now when m is greater than equal to n, the limit exists, but the limit when m is less than n, that limit does not exist. But that does not imply it is divergence, right? It can happen that in that also some point will be there, for that it will convergent. M is less than equal to n, m greater than equal to n, it is convergent always. That is fine. And when m is less than, strictly less than n, then the integral is improper, but we don't know whether it is convergent or not. So that's why we take gx a function x to the power m minus n, and we find the limit comparison test like this we did, and we find out this is as 1. So here you can say that if this integration 0 to pi by 2 x to the power m minus n dx, if this convergent, then our integration will be also convergent. And that from there, what you can use these quantities to n minus m x to the power p, 0 to a x to the power p converge if p is greater than 1, and it will be divergent if p is less than 1. So converge if p is greater than 1. That's what you see. 0 to pi by 2 x to the power m minus n will converge if m minus n is greater than 1. m minus n is greater than minus 1. Sorry, p is greater than minus 1 it will be. So if m minus n is greater than minus 1, that implies n minus n is less than 1. That implies n less than m plus 1, then it will be convergent. Is it okay now? It was a little long, but do you understand? Where is the? Tell me where is the issue then now?
Sir, I have issue on the last part, that integral of gx dx.
Okay, no problem, no problem. Let's do it. No issue. So forget this question. So now I think I'll do it some. Yeah, maybe here. So the problem now only became 0 to pi by 2 x to the power m minus n dx, right?
Yes, sir.
Okay. So let's do it for 0 to a is strictly greater than 0, x to the power p dx, when it will be convergent or divergent. So of course when p is less than 0, it will be divergent. That is not an issue. I mean, what I will write is limit as epsilon tends to 0, 0 to a x to the power, sorry, 0 epsilon to a x to the power p dx. That is nothing but limit as epsilon tends to 0, x to the power p plus 1 over p plus 1 epsilon to a. I mean, I am writing here maybe the limit as epsilon tends to 0, a to the power p plus 1 over p plus 1, p plus 1 minus epsilon to the power p plus 1 over p plus 1.
It's correct, right? This one.
So now what we will see, this quantity is independent of epsilon, first one. So the problem will be here when limit as epsilon tends to 0, epsilon to the power p plus 1 by p plus 1. So when p plus 1 is greater than 0, then epsilon to the power p plus 1 converts to 0. If p plus 1 is less than p plus 1 is less than 1, p plus 1 is sorry, p plus 1 is less than 0, then you don't have any hope, because when p plus 1 is less than 0, let's say p plus 1 is at minus half, then epsilon to the power minus half will diverge to infinity, right? So when this one will be 0 when p plus 1 is greater than equal to minus 1, sorry, greater than equal to 0, sorry, greater than equal to 0, right? Equal to 0 also no problem. If p plus 1 p is equal to 0, then also no problem, right? So p plus 1 has to be greater than equal to 0 in order to show that x to the 0 to a x to the power p dx is convergent. So similarly here also you will see you have m minus n, x to the power m minus n. So m minus n has to be m minus n plus 1 has to be greater than equal to 0. So m has to be greater than equal to, sorry, m plus 1 has to be greater than equal to n. That's the thing you get here. M plus n has to be very appropriate. Anything here? Yeah, m plus 1 has to be greater than equal to n. I think for equal to n also it will be true. Okay, so it means m plus 1 equal to n, then also it will be fine. It's correct now? Okay
Yes,
with
sir.
you?
Yes, sir.
Okay, so let's move to the next one. So do it, this one. Try by yourself. Convergence is mainly you have to tell that what are the values of n, so that this 1 to infinity sine 2x over x to the power n converge for what, which value? N is first of all greater than equal to 0, you assume it. So answer is there. Okay, so we'll use something called Dirichlet principle to prove that this is convergent. Okay. Okay, so the Dirichlet principle says that this is the answer here. So if you have 1 to infinity sine 2x over x to the n dx type of function, you can, if you can show that 1 to b for any b, so infinity is there, 1 to b, any b is greater than 1, this integration is bounded, modulus of this one is bounded. That is easy, right? Because sine 2x is a bounded function, and bounded function on a bounded domain, and it is nice and it has no singularities, so this function will be, the integration will be bounded. So once the integration is bounded, and if you know that x to the power 1 over n, 1 over x to the power 1 by 1 by x to the power n is monotonically decreasing and is converging to 0 as x tends to infinity, then this type of, I mean, it is true for any two function. Let's say you want to find out fg, which is from a to infinity. What do you have to put that a to infinity modulus of f? Sorry, no. A to some r, f of modulus of f, that is bounded. That's less than infinity. For all r is greater than a, and gx converts to 0 and monotonically decreasing, then 1 to infinity fg will be convergent. So remember this one. You have to remember this one, that uh, if these two functions are there, one is monotonically decreasing and converging to 0, and another is bounded for any r, then it will be, the product will be convergent. So for any n greater than 0 is convergent. Convergent is convergent. Okay. Is it okay? Otherwise, please ask me any if you have any doubt here in this question. This is just a Dirichlet test you are using.
No, sir, it's okay.
Okay. Let's move to the next question then. Question 7, question 8. Try to do this question, okay? Okay. This is I think we move to the gamma function most probably. Yeah, we have moved to, I think, gamma function. So gamma function mainly we denote by gamma function, gamma n. Gamma of n is nothing but 0 to infinity to the power minus x, x to the power n minus 1 dx. And you remember that this integral converts if n is strictly greater than 0, and it diverges if n is less than equal to 0. That you just remember, okay? No need to prove and all, you just have to remember that gamma function converts if n is greater than 0 and diverges if n is less than equal to 0. Okay. X to the power n minus 1, e to the power minus x, 0 to infinity dx. This is called gamma function. Some properties are gamma 1 is equal to will be 1. Okay. That because of 0 to infinity e to the power minus x, integration value is 1. Gamma half you have to remember, that is square root of pi. I think square root of pi or square root of pi by 2. I just check it. I wrote it somewhere. Yeah, square root of pi only. And this gamma function, it has a nice property. Say this gamma n plus 1 will be n times gamma n. So I think this three, if you remember, then everything will be fine. So gamma n, what is the gamma n? The integration from 0 to infinity to minus x to the minus 1 dx, and gamma 1 is 1, gamma half is square root of 5, and gamma n plus 1 is n times gamma n, and it will keep on going. And it is diverge, and it diverges if n is less than equal to 0, and it converges if n is strictly greater than 0. Okay. So now let's do 0 to infinity to minus x. 0 to infinity e to the power minus x over x square means to the minus 2. Right. So how you write in this gamma form? This in the gamma form, this will be equal to 0 to infinity, this dx is 0 to infinity to the minus x to the power n minus 1, right? What will be then n minus 1? N has to be minus, sorry, not minus, minus 1, minus 1. I mean, n is here, so n is equal to minus 1, which is less than equal to 0. So, diverge. That's what it is given. If you take the 0 to infinity to the minus x to n minus 1, converge if n is greater than 0, diverge if n is less than equal to 0. So what about 0 to infinity e to the power minus x times x to the power, let's say, minus half dx. What's the value of n here? Corresponding value of n?
So 1.
1. How?
So no, sir.
You have to write it to the minus x time x to the power n minus 1. What is it that n minus 1 value? And depending on the value of n, only you can tell whether divergence or convergence. You compare with e to the minus 6 times
So 1 by 2.
exactly. Good, good. Exactly. 1 by 2. So I mean, if you write this one as 0 to infinity e to the power minus x times x to the power n minus 1, that will be e to the power dx. So n is our here half. So that implies this is strictly greater than 0. So remember, strictly greater than 0. So it will be converged. See, looking like kind of similar. One is x square, one is x to the power minus half. But you see the difference that one is convergent, one is divergent. Okay. Similarly, also you can do to the minus. Okay, that both two only we have done. So you can check it for the 0 to infinity is, let's say, to the minus x time x to the power 7 over 8. What will be the value of n? What is the value of n here? I mean, how you can write this function 0 to infinity to the minus x times x to the power 15 over 8 minus 1, right?
Yes, sir.
So n will be 15 over 8, which is greater than 0. So the see how it became very easy. So we know just find out the value of n and tell that it's convergent or divergent. So here you see n is strictly greater than 0. So the integral will be convergent. Yeah, that's what we have done for the gamma function. Now we'll move to this is called beta function. See, this is the beta function. 0 to 1 x to the power n minus 1 times 1 minus x to the power n minus 1 dx. It converges and it the integration is from 0 to 1. So people make a mistake here. Sometimes it will be 0 to infinity. Which one is 0 to infinity? Which one is 0 to 1? For the beta function, it will be 0 to 1, and for the gamma function, it is 0 to infinity. Okay. So remember, you can remember like this beta is B and gamma is G. So that will be bigger. So beta is from 0 to 1, gamma is from 0 to infinity. Okay. You can have any other better way to remember, but this is one way I have said. So this is called beta function. Beta function. Okay. So beta function. Now the beta function is like this, and then we have to show. I can show that if you can write one integration in the form of beta function, then it will converge if the both m and n are positive. At diverge if both m and n are less than equal to 0. Okay. So let's say for the first one, 0 to 1, x to the power half 1 minus x to the power half dx. How you can write this? 0 to 1 x to the power, yes, 3 over 2 minus 1, right, times 1 minus x 3 over 2 minus 1 dx. That implies m is equal to 3 by 2, which is greater than 0. n is also 3 by 2, which is greater than 0. So converge it. Now you have another question, 0 to 1. 1 over square root of x cube times 1 minus x dx. So these are weird type of integration. You don't know, usually it's very difficult. But if you can write it in the form of beta function, so it becomes a little easy. This is 1 minus x to the minus 1. Still we haven't write in the beta form. This will be equal to 0 to 1 x to the power minus half minus 1, 1 minus x to the power 0 minus 1, right? So m is here minus half, which is less than equal to 0. n is equal to 0, which is less than equal to 0. So diverge it. You had some weird type of function. It's difficult to prove that the conversion or divergent. Use the beta function and say that it's a divergent because m and n values are less than equal to 0. Right? It's good, right? So any issue up to here? If
Sir,
not, then we tell.
sir, what if in case only m or n is positive and other one is negative?
Yeah, then we cannot say anything from the beta function. I mean, there are a lot of things you can. I don't know whether research is done also in this area. I don't know, but till now, what we can say that the if m and n both are less than equal to 0, then only we can say that divergent. Okay, one of them you cannot use this beta function theorem.
Okay, sir.
Yeah, whatever I know, I'll search, maybe I'll look for something. If I get, then I'll tell you. But till now, you use this one way only. Both are less than equal to 0. Okay.
Yes, sir.
I also thought about this. Okay. Good. Okay. So if not, then we'll move to the last question. Okay. Last question of today's class. Yeah. So the last question is about this 0 to infinity. I mean, minus infinity to infinity to the power minus x square. If the minus x square is an even function, right? Even function. If f of minus x is f of x, I mean even function. For an even function, you can always write 2 times, and it's an integrable function also. So it is 0 to infinity to the power minus x square. And you know this integration can be evaluated. I mean it's convergent integration. We have seen already in this today's class itself. But what will be the value of this? So first of all, take x square equal to t. Then what will happen? 2x dx will be dt. I mean dx will be t to the power minus half, right? to the minus of over 2 dt. So when x equal to 0, then t equal to 0, and it 0 to infinity will remain as 0 to infinity. But here it will change to minus t times dx will be t to the power minus half over 2 dt, right? So this 1, 2 will get cancelled. So what we will write as 0 to infinity e to the power minus t. Now can you see this is in a good form, exact form. What is this? Gamma function, which is a gamma function of t to the power half minus 1 dt. That is nothing but gamma of half. And I said you gamma half is nothing but square root of pi, and you got a value of minus infinity to the minus x square as square root of pi. For your reference, I will here it is also written. Check, go through this video, maybe the offline whenever if you want to watch, it will be uploaded in the YouTube. Go and watch, and this one already will be shared with you. The PDF will be shared with you in the I think Google Drive. Link is already shared, and there you will see the lecture notes with all these things I have been doing here. This will be uploaded in the Google Drive. So check it here, and if you have any other doubt, tell me. I will be here for 2-3 minutes, maybe
Sir,
more. Yeah, tell me.
sir, in the last question,
Yes.
sir, I couldn't get it. Minus infinity to infinity, how it was 0 to infinity.
Okay. Let's not do like that. Maybe okay. So minus infinity to infinity, e to the power minus x dx. Sorry, minus x square dx, right? So do you know from minus a to a, e to the power? Sorry, not e to the power. Let's write it as. It's not coming. Fx dx is equal to 2 times 0 to a fx dx if f is even. Do you know this result?
Yes, sir.
Okay, so f is even here, e to the minus x square is even here,
Oh, yes, sir.
e to the power minus fx equal to e to the power minus x square. So f of minus x is nothing but e to the power minus x whole square. That is nothing but e to the minus x square. That is nothing but f of x. So this function is even function, right?
Yes, sir. Okay,
So
sir, I got it.
now it's fine.
Yes, sir.
Okay.
Okay.
Good. Yeah. Any other question from anyone? From anyone else? Okay. If not, then we'll meet again in the next Saturday from 6 to 8, like we are meeting. Please do come and join with me. Okay. You can, if you have any other better way, so that I can teach you in a better way, then you can suggest me also. Okay, that will be good for me and good for you also. And these are some books and references for you. Already is every time I do give, but it's already is there, so that's why I just keep on giving. So yeah, and thank you for your attention.
Thank you, sir.
I'll stop. Okay, thank you.